going to do another direct proof example. For any positive real number x, x plus 1 over x is greater than or equal to 2. Okay, so we're going to try to prove that. By the way, interesting statement. So no matter what the number is, no matter how big or small, if you add a number to its own reciprocal, it's going to be at least 2. Obviously, if the number is very big, if the number itself is already bigger than 2, then we're not really saying much. But if the number is less than 2, even if it's really, really tiny, if you add its reciprocal, it'll be more than 2, or at least 2, right? And so, because if it's small, if x is small, then its reciprocal will be correspondingly big, and it just always works out that it'll always be at least 2. So it's an interesting statement if you think about it. Now, how do we go about proving this? Direct proof, right? So hypothesis and conclusion. What is our hypothesis? What is our conclusion? Well, the only hypothesis we really have is that we have a positive real number. No special properties about it. It's can't say odd or even because it's a real number anyway. Yeah, it's just a positive real number. So suppose x is a positive real number. Okay. Well, we have to get from that, which isn't much, to x plus 1 over x is greater than or equal to 2. I say it isn't much because, when we did the examples where something was odd or even, the definition of odd or the definition of even at least gave us an expression that we could use, right? It gave us something to hold on to and to work with. But x is a positive real number. I mean, we could write x is greater than or equal to 0, but that's not much, and I don't know how we get from there to x plus 1 over x is greater than or equal to 2. Right? So sometimes we're faced with this where it's not clear how to proceed. And one thing we might think to do then is work backward, because we know where we want to end up, the conclusion, x plus 1 over x is greater than or equal to 2. But so let's start there and work backward from there. So I'm not going to type this, but I'm going to switch to just a whiteboard. X plus 1 over x is greater than or equal to 2. What could we do with that? Because we have a 1 over x, I might multiply through by x to get rid of that denominator. So x squared plus 1 is greater than or equal to 2x. By the way, multiplying by x, since we do know x is positive, that keeps the inequality the right way, right? If x were negative, we'd have to flip it, but we know it's positive, so we definitely don't flip it. All right. Now we have a quadratic, and the thing we usually like to do with quadratics is get everything to one side. And I'll write it in the usual way. And of course what we like to do with quadratics. So notice I'm kind of following my nose. Now I personally know how this does turn out, but I think every step I'm doing is a reasonable thing to just try out. What do we do with quadratics? We might factor them if we can, and this definitely can be factored. X minus 1, x minus 1. Now that's x minus 1 squared. And I look at this and I say, well, x minus 1 squared, because it's something squared, it's definitely greater than or equal to 0. So this is definitely true. So this is something that is absolutely true, and I got there from my conclusion. So what I need to do is go back the other way, right? Remember, in a direct proof, you want to end at the conclusion. You're supposed to end at the conclusion. So we actually have to work the logic back the other way. Now every step here, you always have to be careful with logic. Sometimes logic works in one direction, but it doesn't work in the other direction. And that's the danger of working backward from your conclusion. However, in this case, I think every step works if we went in reverse. If we started here and then wrote that, that would be true, of course. Then we would unfactor it. In other words, we would FOIL. Then we could move the 2x over to the other side. And then we could divide by x instead of multiplying by x to get back to here. And then we would end at the conclusion. So that's how we're going to write the proof. The working backward was nice to do on the side to help to give us a sense of how it should work. But now we want to work forward. So what I'm going to do is I'm going to say, how do I want to say this in English? We know x minus 1 squared is greater than or equal to 0. It's certainly true. So imagine your audience. You've told them, okay, suppose x is a positive real number. And now you write this down. Now they might not know where you're going with this so far. That doesn't seem to have anything to do with x plus 1 over x is greater than or equal to 2, the conclusion. So that's a little bit of a mystery, but you're going to fill that in for them. But they certainly would agree with this. They would say, yes, this is greater than or equal to 0 because it's a number squared. So that's great. Okay. Thus, and now I'll go ahead and multiply that out. I'll skip the x minus 1 part. I don't have to write that. I'll just go ahead and FOIL it out. X squared minus 2x plus 1 greater than or equal to 0. Right? So again, my imaginary audience would follow me on that step. And then I'll do the next step, which I know from my scrap work is to bring the 2x to the other side. X squared plus 1 greater than or equal to 2x. And let me start a new line there. Okay. Period. Whoops, what just happened there? Period. There we go. Okay. And now I think my step was to divide by x, right? So let me say, since x is positive, dividing by x gives, so then we'll have x plus 1 over x greater than or equal to 2. Okay, and that was our conclusion. So we got to our conclusion in a logical manner. So again, the working backward from the conclusion can be a really big help to if you're stuck. However, that isn't your proof. You have to reverse the logic, and hopefully all the steps can be reversed. And if they can, then you've got your proof. So we're done.